Hello, everyone. You are welcome to today's lesson. And my name is Mr. Richard Ogwanywa Hackman. I am going to be your facilitator, for this particular lesson. And going forward. So today's lesson will be on, functions. And we are going to concentrate on the native math word function aspects. We've done the core math where we did the definition of functions, how to evaluate functions, and what have you. Today we are going to look at the relative math, aspect of functions. So quickly, let's go and have a look at what our learning objectives. So as a result of studying these topics, the students will be able to, that's the general objective, understand the concept associated with functions. Then we come to the particular objective. So find the inverse of a function, define and identify a composite function, find the composition of functions, or find composite functions. So it means you should be able to define, identify, and find what composite functions. Then apply the concept of composite functions to find simple functions. Define and find the domain of a function. Define and find the range of a function. Determine whether or not a function is one-to-one. Determine whether a function is even or odd. Define an ordered pair function. Determine the domain, range, and inverse of ordered pair functions. Determine whether a graph of relation is a function. And last but not the least, will be determine whether a graph of relation is one-to-one. So this will be the entire learning objective, for the entire topic, functions, relative math. However, today's, objective will end at, I think, finding the composite of functions, or the composition of functions. So please take note, finding composite function, that's where we'll end. So we'll do finding the inverse of a function, defining and identifying a composite function, as well as finding composite functions. So that will be our main objective to today's lesson. The rest of the objective will be catered for the subsequent lessons. So quickly, let's go, and have a look at what we have here. From even JHS and SHS, because you've done, all of you've done the real number systems, you know that anytime you have a quantity, or maybe a letter, let's say A, and I want to indicate the inverse of this A, we know usually you raise the A to the power 1. Do you agree? Do you agree?
Yes, please.
Yes.
Very good. So anytime you see any quantity to the power -1, you are talking about the inverse. But usually when you mention inverse, we think inverse is always what? 1 over the quantity. Is that not it? That's what you know as well. Am I right?
Yes, please.
So this one, it's not wrong. Only that this one, if you do this, then it means you are looking at one operation, and the operation is what? Multiplication. So it's only multiplication that the inverse will be written in this form. However, if I have A and I'm dealing with addition, the inverse of A will not be 1 over what? A. It will rather be negative A. Should I come again?
Yes, please.
Yes, please.
So I said, remember the concept of inverse, in terms of real numbers and our usual or basic understanding is that any number, operating on the inverse should give you the identity element. Any number operating on the inverse should give you the identity element. Those of you who have done binary operation, I think you are privy to this. And take note, I know some of you have done binary operation. You said you have issues with that. I won't treat binary operation in class. I will send you recorded version, maybe during the weekends. You watch, I will attach assignments that you do it. That is just by the way. So if I have, okay, take note, I said that any element operating on, so let me use the operation star, operating on its inverse should always give you the identity element. Let me use. So if my operation is multiplication, let's say A operating on, so times, okay, A inverse should give me E. The identity element and the multiplication, okay, is what? What is the identity element and the multiplication? Who can tell me the identity element and the multiplication? Identity element means an element that if you operate it on another element, it doesn't change
1.
the identity. It's supposed to be
1.
1. Very good. Because you can see that the multiplication, any number times 1 will not change the value of the number. So it doesn't change the identity of the number. So under multiplication, the identity element is 1. So if I'm looking for A inverse and the multiplication, if I make A inverse the subject, you see that I will get A inverse to be equal to 1 over A. You get it?
Yes, please.
So that's
Yes.
where the inverse is coming from. But the inverse is coming from the multiplication, okay, perspective. But, okay, it is not always 1 over A, because multiplication will not always be my operation. So if I have maybe addition, if I have A plus what? A inverse, so my operation now is addition. This should be equal to the identity element under my operation. The identity element and the addition is what? Which element do you operate on another element which will not change the identity of the element in terms of addition?
0.
0. So it means this will be 0. So if I make A inverse the subject here, I will get A inverse to be equal to what? Negative A. You get it?
Yes, please.
So it means in terms of addition, okay, the inverse of A is not 1 over A, it's rather minus A. All correct? Do you get my point?
Yes, please.
Okay,
Yes.
so now indirectly, okay, I've taken you from the known, okay, I'm moving you to the unknown, so you should be able to multiply. Okay, so here, the inverse of a function, so I read the inverse of a function f, and I'm using f as my general function. It could be j, it could be what have you. Okay, so it's denoted by f, you know, f up to the power negative 1. And remember, we said in math, anytime you are looking for inverse of any quantity, just take the quantity in terms of notation, then give the quantity the power of negative 1, as simple as that. So here, our quantity is f, which is a function. Anyway, so if you want to find the notation for f inverse, it will be f to the power negative 1. And this is read as, we don't read it as f to the power negative 1, but that's how you read it. You read it as what? F inverse, or inverse of what? F. Okay, only that I will be using the first one very often. Is my point well made? I will be using the first one
Yes,
often.
please.
Okay.
Yes.
Okay, all right. So now you know the notation, okay, of the inverse function. However, you know, when we were doing, okay, functions, usually we didn't use f. Okay, every function will depend on a variable. So we use f of x, telling us that the function depends on a variable. So again, let's move to that concept or that direction. So that is, if, okay, f of x is a function, okay, then the inverse is denoted by, so it will be f inverse of x. So now you attach your x to what you have here. Okay, and read as f inverse of x, or inverse of what? F of x. So anytime you see this, you read this one as f inverse of x, because you know this is read as f inverse, and this will be x. If you have, this was not there, then it will be f of x. Now, this power is there, so it will be f inverse of what? X. So you know how to read, okay, any function which comes in this notation, the inverse notation. Take note of that. Okay, now that we know, okay, the notation for inverse function, let's look at how to find the inverse of what? Of a function. So to find the inverse of a function, and I'm using a general function f of x, we have to adapt the following steps. Okay, so step 1, let your given function, in this case, my function I said is f of x. So let the given function be equal to y, or let y be equal to the given function. Okay, that is the first step. The second step is to interchange the variable. So once you represent your function by y, and the function depends on x, it means you are going to get, okay, a relation in terms of x and y. Very soon you appreciate this concept better if you are not up there. Don't worry, as we start working with the you verify, I assure you. Okay, so it should be in terms of x and y. The next step is to interchange, okay, the variables. And the variables here, I'm talking of what? X and what? And y. So wherever you see x, you replace it with y, and wherever you see y, you replace it with x. That is what is meant by the changing what? The variable. Then 3, you make y the subject in the relation, okay, sorry, of the relation in step 2. So step 2 here, after interchanging your variables, you still have a relation. At that relation, you make y the subject. Okay, Yasmin.
Please, can you take number 2 again? I didn't quite understand it.
Okay, so the number 2, okay, I said, okay, because the function, you know that maybe the function will be 2, f of s is equal to 2s plus 1. Is that okay? So let me maybe throw, but I told you that when you are dealing with example, okay, you understand better. So maybe my f of x, okay, is equal to 2x plus 1. This is my f of x. Okay, so if I represent f of x by y, then it means I'm going to get y to be equal to 2x plus 1. Is that clear?
Yes, please.
So you
Thank
can see that this is a relation. So if you say, so this one is for the step 1. I'm now looking at the step 2 that you said, okay, you have issues. So if you are interchanging the variables here are, can you tell me the variables?
X and
X and Y. So if you are interchanging the variables, then it means wherever you see Y, it becomes X. And wherever you see X, it becomes what? Y. Simple as that. You get it?
yes, please. Thank
Great.
you.
You are welcome. Okay, so this is what I want. Time you don't get it, please let me know. Okay. And if you don't talk in class in terms of disclosing your issues, okay, after class, okay, please don't tell me that you didn't understand what I taught in class. Okay, back door. You are supposed to be active in class, okay, in terms of asking questions, okay, to better your understanding. Please take note. I won't encourage that. Okay, that one is a no-no for me. All right. Okay, so the last step, okay, will be after making y the subject in step 3, you replace the y that you have there by the f inverse of s. So it means the y automatically becomes the inverse of the function that you are looking for. Am I clear?
Yes.
Yes,
Okay,
please.
very good. So now let's go and look at what examples and how best to deal with it. Okay, all right. So let me. Okay. Okay, so someone is asking, okay, there is another way that you can make S the subject, then later interchange. Okay, so Papaya, okay, let's see. Okay, I don't want to say yes or no, though I know the answer. So what we will do is we will work it out, okay, the questions that you have here, using what I said, meaning you will interchange before making Y the subject. Okay, and then we go by your, okay, suggestion. What you are asking, we'll make S the subject and interchange and see whether we end up getting it.
Yes.
Okay. Only that maybe afterwards I will ask you to, okay, adapt to mine. Okay, so quickly, let's go and look at the solution, okay, to the questions that we have there. So I've told you, anytime you read questions, make it a point to underline the salient part. So here, what are we supposed to find? The inverse. Okay, so you know you are finding the inverse. Okay, I can choose to underline inverse or not. Okay, take notes. Okay, of that. So now, this is what we are going to do. Okay, we've underlined the salient parts. I've told you inverse, you can choose not to underline. Okay, then after that, you come and write solution. That's the first thing that you write. Here, the questions are numbers, so you number as well. So A, okay, you've been given a particular function, so you extract the function. What are we giving? We've been given f of x. Okay, very important to extract, and that is 3x plus what? 2. A very pretty function. It doesn't involve negative. It doesn't involve what? Fractions. Okay, now we need to find the inverse. And we said in finding the inverse, we need to go through certain steps. Okay, the very first step is to represent your function by y. Okay, so you let y to be equal to what? Your function. Function to be equal to what? I. Okay, that's the first step. So don't write step 1. Please take notes. Okay, just come and write. Let's, okay, y be equal to what? F of x. So if y is equal to f of x, then it means y will be equal to what? So this implies that y will be equal to 3x plus 2. Is my point well made?
Yes,
Yes.
please.
Yes,
Very
please.
good. Very good. Okay, so now first step done. The second step, what are we supposed to do? Interchange what variables. Is that not it?
Yes.
Okay, that one too, you
Yes.
have to come and write it. So you write interchanging. You don't write interchange. Okay, it's supposed to be interchanging. Okay, the reason being that in books, okay, you see interchange. You are a student, so it's like you are being commanded. And when you are writing it, please, okay, if you are writing maybe put, instead of writing put, write substitute. You are guiding us, okay, as to what you are doing. You are not instructing your teacher, okay, to do something. So instead of writing, write, instead of writing substitute, write substitute. Instead of writing interchange, okay, write interchange. You get it?
Yes, please.
So that it will not sound like you are instructing or commanding, okay, the person who is marking your teacher. Or okay. So in this case, my point is well made. So interchanging. Okay, the variables. Don't write the variable. Now you know the variable. Get it?
Yes, please.
Okay. So interchanging x and y will mean, okay, this will imply that, okay, your x will be equal to what? 3y plus 2. All correct?
Yes.
Yes,
Great.
please.
You are doing well. Okay, so step also down. Okay, we need to move on to step 3. And step 3, what are we supposed to do? We said make which variable the subject? Why the subject? You can see that here x is the subject, not. Okay, so
Yes,
we are
please.
going to make y the subject. In making y the subject, what do? You maintain the y here. However, when you are making y the subject, don't write y the subject. Okay, your steps will tell us what. No one, don't write it. But the let write it, and what and also write it. Okay. All right. In this case, this is what we do. We are going to have, okay, I will maintain my 3y here. So in my mind, I've maintained my 3y here. Okay, only that I'm going to write it on this side. So I'll write 3y equals, the fact that you see 3y here doesn't mean I have the 3y to the side. Is that clear?
Yes, please.
Okay, so I've maintained it and I will get what? X minus 2. If you like, you can still write x minus 2 is equal to 3y. It's the same thing. Okay, so I will move this one to this side, which will give me x minus 2. Should I come again, or my point is well made? Hello? If you come again.
Yes.
Okay, so once I hear one yes, okay, I will okay, go over. So this is it. What we have here, the comfort zone, usually that's what we want to do. We're making y the subject. So the y term here is positive. So you usually maintain it on the side that is indicated, where it is positive. So here, okay, the right-hand side. So I will maintain it here. So I will write my 3y here. Then move this one to this side, which will give you your x minus 2. Is that clear? Is it clear now?
Yes, please.
Okay, so that's your comfort zone. Okay, you can deal with it. Only that I said, because usually the variable that you are making the subject, want it to be here, okay, on this side. Okay, that's the more reason why here I said it's positive, but I'm going to write it first. And I know I'll move this one because I'm just using the concept of if A is equal to, then B is equal to A. That doesn't mean I move. You get it? Necessarily.
Yes, sir.
Okay, so once you get that, then after that, okay, Yasmin, Prof.
Please, can there be an instance where the um 3y is negative?
Yes, okay, don't worry. Okay, very soon you will know. Okay, you will encounter a situation like that. If it is negative, then it means it calls for movement.
Yes.
Because, or if you maintain it there, then it means you are going to divide by a negative. You get it? In the end.
Yes.
Okay, sure. All right. So change of subject. You can see we are not doing change of subject per se, but what we are doing, we've encountered change of subject. So that's why in math, you don't choose and pick the topics that you like. You have to like all the topics. However, it is allowed to have some of the topics. Okay, all right. So now this is what we have. So we are going to make y what's the subject. When you write it again before you divide, it's take note. So you are going to just write this one as 3y is equal to x, okay, minus 2, then over 3, over the whole of that over 3. Take notes. Okay, if we're going to divide the individual terms here by 3, talking about x over 3, 2 over 3, then that one, okay, you can choose to do it mentally. By any time you are doing change of subject, if you have more than a term here, consider the whole of that term as, the whole of the 1,000 terms or whatever term that you have, whole of the terms as one, and you divide the whole of that by a denominator. So that is once you have this bar, it means you are considering the whole of this as a term. So making the whole of this a single fraction. Is that clear?
Yes.
That's my point well made.
Please.
Okay. So by so doing, what do we get? We get y to be equal to, and you can see that anytime I'm writing, I'm from one line to the next line, I'm writing close to the margin. Can you see that? And I'm creating room here for the rough work. So you can see that if this room was not there, okay, I wouldn't be able to do my rough work for the explanation. So always move your presentation to this side so that there will be space here, okay, for your rough work if need be, or even to continue. Okay, very soon, I will show you the nature of the constraint paper that maybe next week, because I want more students to come up since we are still registering today. Then next week, I will do that by then. Okay, so at this point, we are going to get x minus what? Over what? Over 3. Is that clear?
Yes.
But so after making y the subject, the job is done. It's C, C. Okay, so what do? You just go and replace your y by the function, the inverse of the function. So the function that we are finding, okay, its inverse is f of x. So now this y becomes the inverse function. So I'll write therefore, okay, f inverse of x will be equal to x minus 2 all over 3. All correct?
Yes.
Okay, it's my point well made. And please take note, if this happens to be your rough work, don't forget to strike it out. Every rough work must be cancelled. However, like I told you, you cancel in such a way that it will still be readable. All right. Okay, it's my point well made. Are we all fine?
Yes.
Yes.
Okay, so I can move on to B.
Yes.
Okay, great. So B, remember I've told you, here you were solving the same question. Okay, so you shouldn't leave spaces between your steps. Every line must be used. So the first line, the second line will be by this and what have you. Don't leave any space. Now I'm moving from a sub question A to another sub question B. That's where I leave a line or two. A line or two, maximum 2 lines. Don't go beyond. Okay, so at this point, I am not dealing with lines. So, okay, take note. So now what do we have? B, what are we giving?
J.
Okay, so J of x equal to 5 minus 6x. Is that clear?
Yes.
Okay.
Yes.
Now, what the first step? What do you write? Let's.
Let's.
Okay. What do you write? What will you write? Y be equal to what?
Now.
Y will be equal to what?
GX.
Of x. Okay, good. Okay, now the function is g of x, not f of x. Okay, so g of x. Take note of that. Okay, so if y is equal to g of x, okay, I can use implication here because I can see that what I have here, there is equal to sign there. So I can use implication. I can't use equal to. If I want to use equal to, then I'm keeping the y. So I can write equal to here, and it means y is equal to what I have. 5 minus 6x. Is that clear?
Yes.
If I write implied, then I have to come and write this side again. Because I can now write implied.
Yes, please.
Okay, so currently this is what we have. So the next step is to interchange x and y, your variables. X and Y. I hope my handwriting is legible.
Yes.
Yes,
please.
sir.
Yes, please.
Okay,
Yes.
so interchanging x and y. Okay, remember y is here. So this y will be x. Okay, and that will be equal to 5 minus this x will become y. All correct. Okay, so
Yes,
the one who asked the question, is there a situation where it could be negative? You can see that we encounter such a situation. All right. So, like I said, we are going to, next step is to make y the subject. No right making y the subject. Your success guide us that you are making y the subject. So what do we then write here? We are going to make y the subject. Now you can see that the y term here is negative. So here I always want to, I don't like negatives. Okay, so if I can deal with negative at the initial stages, I'll make sure I deal with negative. Okay, so some of you like negative. Okay, so in that case, you can maintain the negative 6y here, move this one to the side and divide by negative 6. I will not do that. I will always want to do the negative here initially. So I will this one so that it will be positive. So if I move this one to the side, this time I move it's negative. So what do I have? I have 6y will be equal to, because I move, okay, the 6y to this side, it means it's this one that should be to the side. I will get 5 minus x, all correct. Is my point well made?
Yes, please.
Okay, so now we are going to move on to the next page. The next page we are going to, or the next step, what do? We are going to divide, okay, through by what 6, or divide both sides by what 6. Okay, so now you are going to get, we have 6y, you write it again, remember, don't divide the last step. Okay, 5 minus x. Then it will be over 6 over 6. Okay, so your y will be equal to what? 5 minus x all over what? Over 6. As you mature, you have drawn your conclusion here. So going forward, I will tell you the matured way without losing any mass. So now that I know why, okay, what do? I am going to conclude, because y automatically becomes the inverse of the function. So it will be therefore f inverse. Is that what I write? Should I write f inverse?
Yes.
G
No,
inverse.
the function is g. Be careful. So it will rather be g inverse. Is it clear now?
Yes, sir.
Okay, g inverse of s will be equal to 5 minus x all over what? 6. So I'm more or less introducing you to some of the common errors that students make. They think every function is f of x. No. Okay, take notes. It's a function name that you work with. Okay, throughout. Any questions at this point? My professors, any questions at this point?
No.
Oh, wow. Okay, then you are doing well. Keep it up. All right. Okay. Okay, so now, okay, so we are going to move on to, we won't do the C. We are going to look at a situation where your function is rational. A function of another function, it contains more or less a fraction. Okay, so we'll do this first. Okay, one, maybe the second one, and with the help, you can do the F and what and the G. Okay, so quickly, let's move on to, okay, okay, please let me, okay, so we are going to skip C, okay, like I said, and we'll do D. Okay, you will try C, please take notes. Okay, any question that we don't solve in class, try. If you have issues, maybe in our subsequent meetings, you can bring it up for discussion. Okay, so now what do we have? Okay, giving, okay, is it f of x? Yes, f of x. This time around, not a pretty function, okay, because it contains a fraction. It's a rational function. And there is a condition, and don't forget to equally attach that condition. X is not equal to -1. Very important. So anytime you find any function or, okay, every function comes by way of your own introduction or your own computation, and there is a variable in the denominator, it means that, okay, function, okay, is constrained. So you always have to attach the constraint there. And very soon I'll teach you how to, okay, attach these constraints. Okay, so here the question, this one came from the question. So with the question, I can give you a question without giving you the constraint. You cannot give me, okay, an answer where your function is a fraction and it contains a variable in the denominator and you don't attach the constraints. That is the difference. So I could have, okay, ignored this. But when you, okay, get a resultant function and the denominator contains a variable, you cannot ignore the attachment here. With the first two, because the denominators, you can see that with this one, this resultant, okay, function, which came by way of our own work, the denominator does not contain a variable. So obviously you cannot write, okay, not equal to but 0. Because for this function to be undefined, denominator must be equal to 0. So for it to be equal to 0, but here obviously this is not equal to 0, right? Okay, the other one, I think we had, okay, 3 or so. It's not equal to 0. So that one is right. Okay, going forward, you appreciate it better if you are not there. So now, first step, let's, okay, f of x be equal to y, or y be equal to what? F of x. So it means y will be equal to, what is f of x? 1 over s plus 1. Is that clear?
Yes.
Okay, great. The next step is to what? Interchange what? The variable. So interchanging x and y. Okay, what do we have? We are going to get, this will now be x. So it will be, x will be equal to 1 over, this will be y plus 1. All correct?
Yes,
Yes, sir.
Okay, so after that, what do? We make which variable the subject? We make which variable the subject?
Why?
Okay, y, very good. So in making y the subject, what will you do from this step?
Cross multiply.
You cross multiply. I know some of you would have said multiply through by the LCM. Please take note. Anytime you have a proportion where this side is a fraction, okay, you know that it's just over 1. A single fraction, this is also a single fraction. Instead of multiplying through by the LCM, cross multiply. And when you are cross multiplying, please don't indicate your lines, okay, showing the cross multiplication. Here we don't, SHS, we don't allow that. Immediately you do that, okay, we can presume, okay, or assume that constant. Is that the point?
Yes, please.
Okay, so don't indicate, only that indicate that mentally. So it will mean I'm going to get x, okay, into what? Y plus 1 is equal to 1. Do you agree?
Yes, please.
Go on to you. Okay,
Yes.
if you come and write x times y plus 1, okay, for this side, usually you write it this way wrong. What is the difference between this and that? I want someone to tell me. If indeed there is. Okay, Philippa, Prof. Philippa.
Please. In the one down here, it means that x is multiplying only y, but the one on top there, x is multiplying that whole term.
Very good. And you can see that that's what you wanted to, bring on board or indicate. So you equally do same. So at this point, what do? You write it this way. This is the right way. So now you come and remove bracket. So you get xy plus x, is equal to 1. Is that clear?
Please.
Yes, please.
Okay, so you are going to make y the subject. Fortunately for us, there is only one term in y, which is positive, so we'll maintain it here. And what do? We are going to maintain it, which is the xy, and move this one to that side, which will give us 1 minus x. All correct?
Yes, please.
You write it again before we divide. So xy will be equal to 1 minus x all over x, because we are making y the subject. We multiply it, or we divide by the coefficient, I should say. So y 1 minus x all over what? X. Is that clear?
Yes,
Yes.
Okay,
please.
so we know that y now will be the same as the inverse. So you write therefore, which function are we finding the inverse is f? So it will be f inverse of what? X. Okay, will be equal to 1 minus x all over what? Over x. Is that clear?
Yes, please.
Yes, please.
Okay, however, okay, so at this point, in this situation, unlike the first two, examples and solutions, we had only a constant in the denominator. However, this time around, you can see a variable in the denominator. Is that not it? So when you have this situation, you cannot end here. You have to attach the constraints. And this is it. This is how always attach the constraints. Your denominator function that contains the variable, equate that denominator function to 0 and cancel it. So indirectly, this is what you do. You write x, because that's my denominator, is equal to what? 0. Then I will cancel it, meaning not equal to. Because it is only when x is not equal to 0 that my function will be defined. This fraction makes sense. Is that clear? So it means, again, if the denominator was maybe x plus 1, then it would have been another one. Let's see how they got it. Where is it? The s plus 1. You equate to, so you write not equal to what? But this function will not be defined when the denominator equal to 0. So the denominator here, undefined, this function will not make sense when the denominator here, so the denominator here should not be equal to 0. Then you come and solve for x. That will be x equal to 1. So when x is equal to -1, you see that the function that you have here, will be, what do you call it, 0. The denominator will be 0, making it undefined. So here, our constraints will be x, not equal to what? 0. Is my point well made, or I should come again?
Please come again.
Come
Okay.
again. Come again.
All right, don't worry, you are fine, you are covered. All right, so this is it. I said anytime you generate your function, and the function generator contains a denominator, and the denominator equally contains a variable, then it means there is possible certain value or values of what your variable will not make your function dead. So in that case, you go and attach the constraint or the restriction. And I said, how do you attach the restriction? Just come and, I have a number. Usually when you have a fraction, it's very good. Let me take it from this point. If I have a over b, rational number, we said that, if you have a over b, if this is a rational number, if you define it this way and you end here, you get the mass. You see that usually we attach not equal to 0. Do you remember?
Yes, please.
So in the same way, anytime you have a fraction and the denominator, the other one, I didn't write, comma here, I didn't write comma, since not equal to or 0. Here, obviously, since not, you can see that since obviously it's not equal to 0. So if you attach it, you are not making it. because your denominator, which you said shouldn't be 0, is not 0. You get it? There is no way it will be 0. So that one, we didn't attach that. We didn't see it necessary to attach it. Okay, because we don't need to attach it. Is that clear? But here there is a variable.
Yes.
And this variable here, we are saying that it's appearing in the denominator. So just, write your denominator not equal to 0. Then solve for what? X in the denominator. But here, after equating the denominator to 0, you can see that, X is already solved. So you end there. Where you need to solve for X, you come and solve for X as I did here. After equating my denominator to 0, I need to solve for X. So here, sorry, should be not equal to. Forgive me. You still continue with a sign, not equal to -1. Okay, you solve for X, but after solving for X, then you come and attach. Okay, so what you have here, you always come with the X form. Okay, always come with the S form. Okay, so if you need to solve for the X, solve it as a rough word and input your results here. Come and attach it here. Is my point well made now?
Yes, please.
Great. Okay, so now if that's the case, then we are going to do the E. Okay, together. Okay, all right. So, and okay, we will have our water break. So E. Okay, another example involving a fraction. So, okay, so given. What are we giving? Okay, f of x again is equal to, what do we have? 3 over 4x minus what? 2. And here the function came and attach the term with its restriction. Oops. So let's go and equally attach what? The restriction. All right, so what do we do? Our restriction is for this function to be defined, the denominator should not be equal to 1 over 2. And again, you can do that yourself, though it's not necessary. So like I said, you want to determine what to attach, just come and equate the denominator. So you write the denominator for x minus 2 should not be equal to 0. And you solve for x. So it will be 4x is equal to 2. Okay, then you divide both sides by 4. We end up getting x is equal to 2 over 4, which reduces to what? 1 over 2. You get it? And that's how come you have this here. You get the point?
Yes, please.
But it is not your business, to find out whether this is true or not. Okay, it came with a question. So just extract it directly, copy and paste. Okay, it is every business of yours. Then this came from your own generation. So take note. So now, what do we do? First step, let's. Okay, your function equal to y. So y, our function here again is f of x. Okay, so in that case, this means y will be equal to what? What is f of x? It's 3 over 4 minus. I wanted to present this matured. Okay, so let me present the last one matured. So let me, so that is what is expected of. Okay. All right, this one I can't clear. I was just using it to make a point. Okay, so now this is it. Let y be equal to f of x. So straight away, you know f of x is this. You can write, 3 over 4x minus 2. Is that clear?
Yes, please.
Okay,
Yes.
so instead of writing y is equal to f of x before you come and do this, straight away you can do this. So y is equal to this, the same meaning as y is equal to f of x. Is that not it?
Yes,
Okay.
please.
Now the next step is to change what? X and y. So you write the changing. Okay, x, the variables, and y. And every line must be occupied. So I move from one line to the next line without leaving any space. And the next, please take note, we are starting a sentence directly. So it's supposed to be a capital letter. The changing should also be a capital letter. Let me, draw your attention to that. Okay. So at this point, what do you don't think because this is smart, you can write anything. Okay, so now you cross multiply. Because this is a single fraction, is over 1. This is also a single fraction, so you can cross multiply. So in cross multiplying, you get what? Oh, sorry. Yeah, you've not done the interchanging. Okay, I'm jumping again. So let's go. We are going to get x to be equal to what? 3 over what? 4, okay, y minus 2. Is that clear?
Yes, please.
Yes,
Okay, so we
please.
are going to make y the subject. So that will call for cross multiplication. So we'll get x, okay, into 4y minus 2. Okay, then at this point, what do? We remove the bracket. So we are going to get what? 4xy minus 2x is equal to 3. All correct?
Yes,
Yes,
please.
Okay. What are we doing? We are making y the subject. There is only one term in y here. Okay, so we are going to maintain it here and it's positive. That's why we are maintaining it here. That's one side. So get what? 4xy, okay, will be equal to either 3 plus 2x. I want to write my variable term first because it's positive. I can start with any of them. So I write this will come in into positive. Take note. This will come here. This is positive. So it will give me 2x plus 3. That doesn't mean if you write 3 plus 2x, will mark you wrong. Addition is committed to this. So now what do? We write it again before we divide. So we are going to get what? Okay, 4xy is equal to 2x plus 3 over, what do we divide by?
4x.
4x.
Okay, very good. So the coefficient, okay, which is 4x, very good. All over what? 4x. So you get y. Okay, at this point, okay, I will not write y. I'm matured. I know that the y automatically will be like this. So I can draw my conclusion. You get a point. Okay, I saw a
Yes,
hand up,
please.
or it was a mistake. Somebody okay, went up. Was it a mistake? Okay, Papaya. Okay, it was a mistake. Okay. Remember I said we'll look at it from your approach as well. I've not forgotten. Okay, Prophet Refua.
Please, I wanted to ask that at this point, there's 2 and there's 4, which are factorable. Do you have to like cancel out
Okay, I was going to speak to
or
that.
eliminate?
Okay, immediately you cancel the 2 and the 4. Okay, you disclose your immaturity in math in terms of algebraic expression. And I'll tell you why. Okay. So meaning you can't do that, and I will tell you why. Okay. All right. So now this is what we have. So at this point, we are going to write this. Okay, we won't do any cancellation for now. Okay, so we can draw our conclusion. You understand that we can draw our conclusion because we are going to get y here. So f, is it f? Yes, f inverse of x will be equal to what? 2x plus 3 all over what? 4x. Is that clear? Is my point well made, my professors?
Yes, sir.
Okay. However, can I end here? Per what I've told you, can I end here?
Yes, please.
No, you can't. Okay, you can end there, but it will come back at a cost.
Please,
So
you can't end there.
You can't end here because the denominator contains a variable. So it means, okay, your x is restricted. Okay, so comma. Then remember I said, how do you get the constraint that you are supposed to apply? Just come and write this. The denominator for this to be fine, the denominator should not be equal to 0. So your denominator is 4x, and that should not be equal to 0. Come and solve for x, and you can see that you get, okay, this over 4, this also over 4. It's my rough way. That's why I'm not writing about x, 4x over 4 with x. It's not equal to 0 over 4 with 0. Any number over, 0 over any number is what? 0. So it's 0. So here I'll write x, okay, not equal to, okay, 0. Is that clear? Because if x is 0, I'll get 4 times 0, making my denominator 0. Is that clear?
Yes, please.
Okay, so now to, okay, Jacinta. Prof. Jacinta, are you there?
Yes. Sir, please, is it always that like it will not be equal to 0?
Yes, you know, that for every fraction to be defined, the denominator should not be equal to 0. Other than that, you get
Okay.
undefined. You like take your calculator and do 2/0, it will give you math error.
Okay.
You get it?
Thank you.
Great. All
Yes,
right.
sir.
You're welcome. Okay. So now I'm going to explain why you can't cancel. Okay. This, okay. 2 and the 4. Remember, before you can cancel anything, if I have A, okay, B over what? A, I can cancel this A and this A because, okay, the A here and the B here are multiplying. They are factors. But immediately I come and have A plus B over what? A. This A here is not a factor, it's now a term. Do you agree?
Yes.
Okay.
So I cannot cancel this and that. Immediately I do that, I've not been fair to this. Okay, because you can see that this number is equally going to divide this. So if I cancel it, then it means I've not been fair to this particular, because what I have here is the same as A over A and plus B over A. So if I cancel it this way, then it means, okay, I am going to get only B. Meanwhile, the B should have been divided by the A.
Like when the universe.
You get the point now. So my point is take it,
Yes, we
okay, line and sinker. My point is, okay, anytime you are going to cancel, sure the numerator, the denominator, okay, what you have there are factors before you can cancel. That's the more reason why if you have, okay, 4, okay, over 2, you can get this as what? As 2. Because what you have is the same as 2 times 2 all over what? Over 2. And because it's multiplication, this can cancel and give you 2. You get the point?
Yes,
Okay, so if my point is well made, I think it can now go. Any questions at this point? Hello, any questions at this point? All right, we thank God you are fine. So my X here is not looking pretty, so let me write it. Okay, so that's my rough work. I'm clearing it. Okay, it's not any rough work connected to this. Okay, so in this case, okay, I don't need it there. All right, so we are doing well. Let me see if indeed I'm recording. Okay, I am. Okay, so now I'll write my X again. So X, oops. Okay, so X not equal to what? 0. Okay, so at this point, okay, let's see. I'd wanted to end at E, but let's go and look at a situation. You can see that this situation is different from this. Okay, I mean the first two, with the two above, the D and E. With the D and E, you had a variable only in the denominator. Okay, but with this one, you have a variable in the denominator. So let's handle, okay, this particular one and see, okay, what will happen in that situation. There will be an advice that will be given that will help you do justice to this question. Is that clear? So let's finish with that one, then go and have our water break. So at this point, I am going to, okay, F. Yes, okay, so F, can I come down? Let me come down. So F, okay, giving, what am I giving? H of X is equal to 2x minus 3 all over x plus 2. And you are told that x not equal to negative. And you can see that, okay, you now know how this was, okay, arrived at, okay, this was, okay. So now, right, x plus 2 not equal to 0, and you solve for x. So x will not be equal to minus 2. Okay. I've told you that's not your business, just write it. Okay, so now first step, now we are matured. Y to be equal to the function h of x, but h of x is this, so 2x minus 3 all over x plus 2. All correct?
Yes, please.
Okay, the next
Yes,
step is to
please.
what? Interchange x and y. So interchanging x and y. What do we get? X should be equal to what? 2y minus 3 all over what? Y plus 2. All correct?
Yes, please.
Okay, so what will be our next step? We make y the subject, which will call for cross multiplication. Is that not it?
Yes, please.
Okay, so we are going to cross multiply. Let me see if you can help me. I don't want to go back. So it will be x into s plus 2. Okay, then 2y minus 3. Okay, so I think now I have it. So we are going to get x into, okay, y plus 2 is equal to what? 2y minus 3. Am I right? Hello, am I right?
Yes,
Yes,
please.
please.
Okay, good. So now you come and expand. So you get what? X, y, okay, plus what? 2x is equal to what? 2y minus 3. So unlike the previous examples, okay, I think the first 4 or there's first 3 or 4 examples that we've done. Okay, you realize that after your cross multiplication and your expansion, you had only one term in y. Okay, so we isolated only one term. Here we have more than a term in y, and this is the advice. Please take note, this is the advice. Okay, anytime you encounter a situation like this, where you have the option, you have two, okay, terms containing the variable that you want to take a subject on each side, one on each side, please take note, this is what you do. Okay, because you are at liberty to move, because I can move this term to this side. Okay, move this one also to this side, so I can move anyhow. However, there will always be one ideal movement, and this is how you get your movements. Okay, please take notes. In your movements, you move in such a way that, okay, your movement will result in least number of negative terms. Your movement will result in least number of negative terms. Is that clear? So now let's see. We are at liberty to move. So let's move and see the movement that will bring in least number of negative terms. So assuming I'm maintaining this one. Okay, let me do the normal movement. Okay, so let me do the normal movement because usually you want to move to the side. So let's do the normal movement and come and move to the side to and see which one will give us least number of negative terms. So I am going to do that here. If I move, okay, the 2y to the side, I'm going to get xy minus 2y is equal to what? Minus 3 minus what? 2x. Do you agree?
Yes, please.
How many negative terms do you see in this relation? How many negative terms? 3.
Three.
This is a negative term, this is a negative term, this is a negative. So we have 3 negative terms here. Is that clear?
Yes, please.
Yes, please.
Let's do the other movement too and see the number of negative terms that will result. Okay, so if you are moving, the other movement will be moving this one to this side. So if you are moving that one to this side, then they will be equal to here. Then you get 2y, okay, then what? Minus xy, am I right?
Yes, please.
So it means this will be maintained here, the 2x will be maintained here. Then this will come here, so you get plus 3. Am I right?
Yes, please.
How many
Yes.
negative terms can you see in the results from this movement?
1.
1. So per the advice that I gave you, which movement would be ideal? First or second?
Second.
Second movement. Do you get my point?
Yes, please.
If you move in this way, there will always be one step, okay, which will be you are supposed to factor out the negative and cancel later. That would be a waste of time. So always think before you write. Okay, and by thinking before you write, I mean, in this case, you know, whenever I have that option of moving, that flexibility of moving, I move in such a way that I will get least number of negative terms. So before I even come and write whatever that I'll write here, I will move mentally. And that's what I have done here. Here, you could have done this mentally. And because I wanted to show you, okay, exactly what I meant, that's why I did it here. So if I'm moving, okay, this one, okay, my usual movement, immediately I bring this, I'm going to get a negative term. Negative term. This will be, I'll get 3 negative terms. This one I move, this will be negative, this will be positive. So I will have this number of negative terms. So I'll rather move, okay, this one to this side. So I'll write this as 2x plus 3 is equal to 2y minus xy. Afar, is my point well made?
Yes, please.
Yes,
Okay,
sir.
so at least you've learned something new today. Okay, so make sure you apply it. That's the beauty of education. You should be anxious to apply, okay, anything new that you learn. Okay, so at this point, we are making what? Y the subject. Okay, we always want it to be here. So I'm going to indirectly, okay, so I will still work it out here. So I'll write my 2x plus 3 is equal to, then come and factor out y. So y into 2 minus x. Do you agree?
Yes, please.
Okay, all right. So now we are in a comfortable lead. So we know what to divide both sides, okay, by. So you write it again, then you divide. So you get 2x plus 3 is equal to y into what? 2 minus x over what? Okay, this is x. It's looking like 2. Okay, 2 minus x, then over 2 minus x. Hello, are you with me? Okay, all right. So we have made y the subject. So in there is like y is equal to this, or this is equal to y. So once you know you cancel and you get your y, remember I told you at that step you can draw your conclusion. So it will be therefore, what is the name of your function? H. So it will be, okay, so now you can conclude at this point, take note. So it will give you your h inverse of x because your function is h. Okay, it's equal to what you have here, which is what? 2x plus 3 all over 2 minus x. Can we end here?
No, please.
Okay, so here, remember, there is a variable in the denominator, so we have to go and do our rough work. As you mature, you can even do it mentally. So it's like 2, my denominator should not be equal to 0. My denominator is 2 minus x, it shouldn't be equal to 0. I come and solve for x, so I will move the x to the side. So I will get 2 not equal to x, which is the same as x not equal to 2. So I'll write x not equal to what? 2. Because if x is equal to 2, my denominator will give me 0, making this fraction undefined. Afa. Hello, are we all fine?
Yes, please.
Please.
Okay, very good. All right, it seems you are complaining of network at your end. Okay, so please let's manage. Okay, I will send a video, then you use that one to complement, okay, whatever that you got. So if this happened to be your rough work, which could have been done here anyway, so that you save the space, okay, then you cancel it. Don't forget that. Okay, is my point well made?
Yes, sir.
Okay, so at this
Yes,
point,
please.
we are going to have our water break. Okay, I'm going to give you 3 minutes water break. When you come back, we'll look at what composite what functions. By 8:30, you should all be back. Okay. All right, so now we are done with how to find, okay, inverse of a function. Okay, irrespective of the nature of the function, whether it is a polynomial function or a rational function, a function over another function, we know how to find, okay, an inverse, okay, or its inverse. All right, now we are going to look at our next concept, which will be composite for functions. Okay, if I may ask at this point, okay, when you hear or see the word composite, what comes to mind? What comes to mind? Hello, my professors, are you there? Composite. Okay, or indirectly, I want you to give me the synonyms. Composite. Uh-huh. Did I hear someone? You put up your hand and you will be given the opportunity to talk. Composite. What do you understand by the word composite? My professors, are you there? Oh, I know at least one person should be able to say something. Composite. Compo. Okay, Prof. Della.
That is compound.
Compound. Okay, not bad. Okay, Indala. Okay, any other? Okay, so compound will do, okay, several. Okay, indirectly. So it means all along, all the functions that we are dealing with are simple functions. You can see that the function is f, is f. If the function is j, is j. The function is h, is h. Okay, we're dealing with simple functions. Now we are going to look at what composite, what functions. So in this case, we are going to work with, okay, 2 or more functions. However, today we'll restrict ourselves to 2 functions. So quickly, let me read what we have here. It's just a simple, okay, concept that you will get. Okay, so a composite function is formed or created when one function is substituted into another function. So whenever, so it means here, we said one function is substituted into another function. So it means you are working with more than a function. And I said I'm restricting myself to 2 functions. So you are feeding one function with another function. So whenever you have this situation, your resultant function, okay, or your output function becomes a composite function. Okay, so therefore a composite function uses the output of one function as the input of another function. The output of what? One function as the input of another function. So it's just like what the, a manufacturing section. Okay, if you feed a particular machine, okay, the machine maybe will, assuming maybe I'm preparing a soap, a bar of soap. I'm just putting it that way, okay. The machine will give me, I have a machine, I will feed it with the soap, okay, or feed it with the materials that will make the soap. Okay, the soap will come in its bar form and it will be put into another machine. And the machine maybe will wrap the soap and package it well. So it means in that case, my first output, which was the bar soap, okay, became an input for the second machine, which gave me another output, which was the wrapped what? Bar soap. Is my point well made?
Yes.
Okay, remember functions are basically operation machine. You feed it with something and you get a result. Okay, so like if my point is well made, then let me throw a little more light on that. So if f, okay, f is a function and j are functions, then the composite function or composition of f and j can be formed in 2 ways. So I have a function f and a function j. I can look at f to be my input function and okay, j to be my input function or output function and vice versa. So one way, okay, of forming, okay, composite function with these 2 functions is to find f, okay, of j. And this is how you read this. Okay, I intentionally didn't write it here, okay, as I usually do because I want you to listen. Okay, this symbol that we have here, the small o that you see there, okay, is what we call the composite function notation. Notation. So anytime you see 2 functions joined with this symbol, you should know that you are dealing with what? A composite function. So indirectly, we now know how to identify composite what function. So I said you can form your composition in 2 ways with the functions f and j. One of the ways will be what we have here, f of j. meaning the composite of F and what? And G. So the O, small o that we have there is read as off. Off for the letter O indirectly, if you can understand it from that perspective. So this will be read as F of G. And F of G means F, you feed it with what? G. So you can see that G of X is now the input for the F of X, for the F. Is that not it? Can you see that? You know that for every function, the input, okay, is what we put in brackets. So our input for this function F is the whole of the G of S that we have here. And in the same way, I could have formed the composition this way. Okay, G of F. Okay, and for G of F, the function that comes here, I will explain further with this information here. So G of F of X means G, I feed it with what? F of X. So take note. So, and this is the note. Okay, F of G means that we substitute the inner function. What is your inner function? The inner function is the function in what? In green. Okay, all right. And your outer function is this, F. So for every composite function, you have an inner function and an outer function. The outer function is the function to the left of your composite function notation, which is the off. And the inner function, okay, will be the function to the right of your composite function. Should I come again, notation? Should I come again?
Yes, please.
Yes,
Okay.
please.
All right. Okay, it's just a notation and how to go about it. So anytime I have, this is the notation, I have two functions. The notation for forming the composition of functions will be this. Okay, so if I have the functions f and what? J, I can form the composition this way. F can come here and J can come here. Or the opposite. Okay, off will be here. The composite notation, J can come here and F can be here. Is that not it? You get the point from here. Are you fine? So this is how you form the composition of two functions, F and J. Okay, however, each composition will have its meaning. Okay, the result here will not be the same as the result here. So the meaning of this one is that, remember every function, when I give you F, I said that we can write it as what? F of S as well, because the function will depend on S. So in the same way, if F is a function and G is a function, then if I find the composition of these two functions, okay, it will also be a function. So I can call this one as F of J of X. Is that clear? So even when you have F of X, okay, you can write this as this. Okay, F composite X, which is the same as F, you feed it with what? X. Is that clear? Only that usually we don't write it this way, but that is the basic understanding. Okay, so anytime you have this, I can attach what? X also here, because this will also be a function of X. So that this will be equal to my F, okay, which is my outer function. I feed it with my inner function, or the out, sorry, the inner function is here. Sorry, forgive me. So this is the outer function. Let me use the cursor. The outer function and my inner function. So I will feed my outer function with my inner function. So my outer function is F. I'm going to feed it with my inner function, which is J of X. So that is the meaning and the interpretation of F of J of X, or F of J for short. Okay, so in the same way, this will mean my outer function, I feed it with my inner function, and once you are going to feed your function, bracket will come. Then your inner function will be F of X. Is that clear? And that's what we have here. Is my point well made?
Yes.
Yes.
Okay, very
Please.
good. Okay, so now that we know the notation and what, okay, it means, let's go and look at how to find the composition of functions. Okay, so quickly, let's look at the following examples. Okay, so this is where we will end. All right, so now we are told, so first work example 1. Okay, if F is such that X maps to S plus 1, so we've been given 3 functions. However, these functions are in which form? Which form of functions? Those of you who were with us when we did the call-out functions.
Please, the mapping.
The mapping, okay.
Relation form.
No, not the relation. This one is the mapping or arrow form. Relation is where you see the equal to. Is that clear?
Yes.
Yes,
Okay,
please.
good. All right. So that was not the relation, it's the mapping or the arrow form. Okay, so now this is what we are going to do in terms of solutions. Okay, remember, okay, we said anytime you read question, underline the salient parts, if any. Here, no, I don't have any salient parts. The functions will be extracted. They are very important. I will extract them. So question, solution. Okay, questions are numbered because your solution must be numbered. Okay, question 1. You need to extract your function. So let's go and extract our functions. Given, do I extract the function in the arrow form?
No, please.
Okay, so remember, you avoid extracting the function in the arrow form. You extract it in the corresponding relation form. So that would mean f of x is equal to, okay, x plus 1, comma, then the relation form of g of j is such that will give us what g of x will be equal to, okay, 2 minus x. And the relation form of the function h, okay, will be h of x is equal to what? 3x minus what? 5. All correct? Hello, is my point well made?
Yes, please.
Okay, so now, okay, to the more reason why. So A, what have we been given? F of what? J of x. Is that not it? So immediately we see this, we know this is the composite notation. So we've been asked to find the composition of these two functions, f and what? J. Okay, however, we are finding f of j. So this now is your outer function, this is your inner function. But we know by interpretation that and definition that this will be equal to what? F, you feed it with what? J of x. Is that clear? Hello, is my point well made? Who wants me to come again?
Yes, please.
Sir, please come again.
Okay,
So
all
please
right.
come again.
Okay, no problem. This was given, is that not it? Now we know that
Yes,
anytime we have f of j, okay, this is the same as what? The outer function, you feed it with your inner function.